Okay, I promised you a trick. What if we want to form the enolate on the most substituted side of a ketone? How do you do that? Well, we can't use LDA because LDA will always give you the enolate from the least substituted side, which is we call the kinetic enolate. It's simply faster because of the steric hindrance. So let's get rid of the LDA. Instead, what we're going to do is we're going to do a reaction. Actually, that's the wrong arrow. We're going to do a reaction using a base. I'll do pyridine. And we're going to use a silicon. In fact, we're going to use tetramethylsilyl chloride. So here's our methyl groups. And here's our chloride. This is trimethylsilyl chloride. Now, silicon loves oxygen. So the way this reaction works is the oxygen will attack the silicon, and then the pyridine will pull off a proton, and will end up forming what's called a silyl enol ether. That's a lot of words. Let's look at it. So here's our enol, which if it had a hydrogen, it would be the enol, but we put a silicon on there, so we've trapped the enol. This is called a silyl enol ether. They straightforward to form, and they form on the thermodynamically most stable side. In other words, the alkene, which gives you the most substituents on your alkene. So we've got this compound. Now we can play with it. Can we alkylate it? Well, no, we can't alkylate it. Sorry about that. But what we can do is we can react it with methyl lithium. Why methyl lithium? Well, see how we already have those 3 methyls on that silicon? Well, if you hit it again, what will happen is that you will form an enolate plus tetramethylsilane. The other product, which isn't shown here, is tetramethylsilane. 4 methyls on the silicon. So look what we've done. By making this silyl enol ether first, then hitting it with methyl lithium, we've made the other lithium enolate, the one that we don't get from the straightforward reaction. Now we can use this one in a alkylation reaction. So let me get rid of that TMS, not to confuse Oscar. We'll draw an arrow down, and we'll do some simple alkylation. Let's just make it an easy one. We'll add bromoethane. So here we've added bromoethane. Press the magic button, and there's our product. So we've added the ethyl group to this position here. So it's an extra step in there, but we get to where we're going.